All right, let's dive into something that sounds like science fiction, but is happening right now. We're going to explore how a regular digital camera, yeah, probably just like the one in your pocket, can be turned into a seriously powerful scientific tool for measuring the health of turfgrass.
So you look out at a patch of grass, could be a sports field, a golf course, whatever, and you ask a simple question: how healthy is it? Seems easy enough, right? But actually answering that question with any kind of real accuracy, well, that's a whole different ballgame. I mean, just look at this picture. It looks green, sure. But how green? Is that a vibrant, thriving green, or just a kind of getting by green? Is it 70% covered, or is it closer to 80%? You see the problem, right? My definition of healthy green might be totally different from yours. Our eyes are amazing, but for this kind of work, they're just not objective. And when you're managing turf, opinions don't cut it. You need hard data. To get those hard numbers, we have to push past what our own eyes can tell us. We need a way to quantify what's really going on out there. And this is where things get really, really cool. You might think we need, satellites, specialized drones, some super expensive lab gear. But what if the solution was way more accessible? What if the key was that powerful little camera you carry around with you every single day? That's the whole idea here. We're going to treat a totally standard camera like it's a portable laboratory. And it all starts with a process that is almost ridiculously simple. Literally, all you have to do is take a picture. That's it. Well, there's one tiny catch. You just have to make sure you include this little guy in the frame, a color reference card.
Okay, so this little card, it's the secret sauce. It's got these patches of very specific, scientifically known colors. By having it in the photo, the software can look at it later and correct for everything. It can say, oh, the sun was really bright, or it was a bit cloudy, and it adjusts the colors across the entire image so they are perfectly scientifically accurate. It's our anchor to reality, it's our control.
So, once we have that color-perfect photo, the next step is to teach the computer how to see color not just as a pretty picture, but as cold, hard data. And to do that, we have to talk about something called a color space. Honestly, the best way to think about it is like a language. Just like humans use English or Spanish to describe the world, computers have their own languages, like RGB or HSV, to describe color.
Now, you've probably heard of RGB, red, green, blue. It's great for your TV screen. But for what we want to do, we need a language that works more like our brains do, and that's HSV. It breaks color down into hue, which is the pure color, like green, saturation, which is how intense that color is, and value, or how bright it is. And that separation, that's the key to everything.
And this is exactly why HSV is such a game changer. By telling the computer to only look at the hue, we can find everything that's green, whether it's sitting in the bright sun or hiding in a deep shadow. We're isolating the pure color, which is exactly what we need. So what does this actually let us do? Well, using this HSV language, we can now digitally sift through the entire image, pixel by tiny pixel, and sort everything into these really useful categories. Check this out. On the left, there's our original photo. Now watch what happens when we apply that green hue filter. Boom! On the right, the software has found and highlighted every single pixel that qualifies as living green grass. It's like a digital magnet for plant life. And why stop there? We can just as easily tell the software, okay, now show me all the yellow hues. And just like that, we've perfectly isolated all the dormant or dead material in the shot. And for the grand finale, we run one more filter, this time looking for the colors of bare soil. Now we've done it. We've completely dissected the image into its core components. So, look what we did. In just a couple of clicks, we've transformed a simple photograph into a real data set. We are no longer guessing. We can now say with mathematical certainty that this patch of turf has exactly this much green cover, this much yellow cover, and this much bare soil.
Okay, this is the moment of truth. Does all this fancy pixel counting actually mean anything in the real world? Does it correlate with actual turf health? Well, the answer is a resounding yes. And the results are kind of staggering. I mean, just look at this chart. On one axis, we have a color measurement taken from the photo. On the other, we have the actual percentage of green cover measured physically on the ground. And the result is a nearly perfect straight line. That R-squared value of 0.97, that's just incredible. It means the photo can predict reality with 97% accuracy. It's basically a perfect match.
And just to prove it wasn't a fluke, here's another index pulled from the photo.
the dark green color index. And again, you see this incredibly strong, predictable relationship. This just confirms it. The data we're pulling from these photos is the real deal.
Now this might be the most important slide of them all. That value on the bottom, NDVI, that's the gold standard. It's a measure of plant health that you usually need expensive sensors on drones or even satellites to get. And on the vertical axis, our simple green pixel count from a regular camera. The fact that they line up so well is mind-blowing. It means this super simple low-cost method gives you data that's comparable to the high-tech industry standard.
So what's the big takeaway here? This isn't just a neat party trick. This simple photographic method can give you reliable, hard numbers on the percentage of green cover, turf density, and can even give you strong indicators of things like nitrogen levels and the overall vigor of the plant.
So let's just bring it all home. We started with a subjective glance at a lawn, and we've ended up with precise, quantifiable, scientific data.
And the big idea here is that powerful technology doesn't always have to be complicated or expensive. By just understanding the basics of how digital color works and by using a simple, controlled method, a totally normal, consumer-grade camera gets transformed into a legitimate scientific instrument.
And that really leaves you wondering, doesn't it? If we can pull this level of detailed agricultural data from a simple picture of grass, what other complex realities, what other hidden stories and data points are just waiting to be unlocked by those powerful little cameras we all carry around with us every single day?